Hello and welcome to our first real application, or the first real measurement, let's call it, where we do not just use input and outputs. Of course we use them, but as a tool. The first thing we want to do is to measure light intensity. Okay? How this is done? We are using this thing here. This little thing is a so-called photoresistor. What is a photoresistor? A photoresistor is changing his resistance, his electrical resistance, with light. If there's a lot of light, it will have low resistance. If there's low light, it will have high resistance. Okay, so this is how the thing is working. To show you a little bit better, I'll show you on my screen. This is the thing I'm talking about. Here you see a bigger picture. This is this photoresistor, and you see the resistor element. Yeah, it's a semiconductor, and this has the thing that if there's a lot of light, it's low on resistance. Okay, so minimum voltage or minimum load on one output, of the Arduino here is around 1 kilo ohm. So we'll use this 1 kilo ohm resistor here and plug it between ground and somewhere. Okay, because even if this is now dropping to very low values, let's say it's dropped to 0, because it's so bright, it is a perfect conductor then. Yeah, it drops to 0, then we would have at least this 1K in serial. Okay, this is it. And you notice, some of you hopefully notice already, that we do basically have the same thing like before with the two resistors. Now we have one resistor which is changing and one fixed resistor. So the voltage level of this point here, this will change simply. Because if we have here plus, yeah, and this is very, very bright light, yeah, then here we will have very low voltage drop because it's very low resistor. So for the current flow through the resistor, it will not take too much voltage. So here we are very high then. With high light, with high brightness, we are high on voltage here. And if it's getting low, yeah, the light, then this resistor will get bigger and bigger and bigger and bigger. And we will need more and more and more and more voltage to let the charges flow through the resistor. So then this voltage level here drops, because from here to here the voltage drop is increased. Okay, so this is what we're going for, what we're looking for. So we just measure the voltage level at this point, yeah, with our analog input, and then we know what this little photoresistor is measuring. Yeah? To see if this is working, you do not have to do this, yeah? But to see if this is working, I will now switch my multimeter. Okay, that's not perfect, so I will just lay it on the table. I will switch my multimeter to ohm mode, and I will measure the ohms of my resistor here. And here we have, what do we have? Come here, 0.9 kilo ohms. Okay, 0.9 kilo ohms, Hopefully this stays. If I try now to do it live. Okay, working. I turn off the light now. Turn off the light. And it increases. Now we have 2.3.2 overload, 25. Yeah, seems to be somewhere at least higher. Yeah, 3 kilo ohms. Yeah. Turn on the light again. Look. See if I can hit it again better. 0.8. Yeah. If I cover the resistor, it is increasing. 3 kilo ohms. If I uncover, 0.8 kilo ohms. So this is because of the brightness. Okay, so this is indeed changing the resistor value. So how to contact this? Yeah. I will again do my bracket on this side here. Plus plus, minus minus, minus minus, minus minus. Of course I have the power supply from my Arduino, minus, and I do have plus 5 volts. Yeah. Now this here I already put into 0 volts. I will have to take the voltage level from here and connect it to my analog input 0. Yeah. And then of course I have to bring the 5 volts somehow is good, somehow to my network, simply by connecting 5 volts. Yeah. Bend it a little bit so that we can see it better. Okay, so that's the hardware setup. I will now plug in the Arduino. Okay, lights on. So this is still has no short circuit. That's working. Something happening? No. Huh? So let's have a look on the program. I'm just using exactly the same program I've used the last time. Yeah, I will upload this program now. I think it's still on, but I will upload it. Take a look at the serial monitor, and there I see. Okay, we read currently a value of 557, so 54.45%. Blah, blah, blah. Okay, I will cover now, or I make a shadow. Look, the shadow is having effect. Okay, if I shadow it, if the brightness goes down, also the measurement goes down. And if I cover it completely, the measurement goes down to 16%, 17%. If I uncover it, it goes up to 54%. Yeah? So this can be even looked better with this serial plotter. Then we should get our lines. Here is our line. Let's have a look on the red line. If I cover now, you see it's dropping. If I uncover, it's increasing. Okay, if I turn off the light, look, it's dropping. If I now cover, it's dropping even lower. Okay. So this is working exactly how we expected, and it's not a big thing, right? I mean, it's just a voltage divider like we've used in our introduction into analog inputs. Okay. When you remember, your task with analog inputs was that you should turn on and off the brightness of an LED. You now can use it exactly the same program you programmed there, yeah, with the LED. Yeah, you can use here, yeah. And then if the ambient light is dark, the LED will get dimmed, and if the ambient light or the measured light, the measured brightness is high, the LED will get brighter. Okay, you know such behavior from your smartphone. Yeah? Your smartphone will dim the display if it's getting dark. Yeah? If you go inside the house, from the bright terrace inside the house or inside your flat or whatever, from outside to the inside, the display will be dimmed down. You will notice. And this is exactly doing the same. Okay? So if you're just using the same program as you have coded before, this will work. So this is how it should work. Yeah? Right now we have some brightness, and if I cover our sensor, you notice the brightness of the LED is going down. So our control is reacting on the brightness of our measurement. Okay? So right now it should just be this hardware setup, okay, for you. Good. So thank you very much for listening. Yeah. Next time we will not measure the brightness. We will measure the temperature, but pretty much with the same principle. Okay. Okay. Thank you. Goodbye.